Welcome back. So, this is lecture 11 in this course Mathematical Tools for Cognitive Science. The topic of this lecture is Introduction to Trigonometric Functions. Okay. So, in the next 5 lectures, we will be covering trigonometric functions, which is an important topic, and even if it is not directly applicable in your research, you will still learn a lot from this, and it will help you understand certain concepts in a better way. Okay. So, we will be covering different trigonometric functions, trigonometric identities, and how to solve problems, equations containing trigonometric functions. Okay. So, I will start with the simple problem. Okay. So, suppose there is this wall. Okay. I am representing a wall. This is a vertical wall, and let us say this is the ground, this is some horizontal ground, and let us say there is a ladder is standing against this wall. This is a ladder is standing against the wall. Okay. Suppose we need to find out what is the angle of this ladder with the ground. We need to figure out this angle of the ladder with the ground, theta. Okay. Given that you know the length of the ladder is, let us say, r. Okay. And maybe let us say you also know the point where this ladder touches the wall. So, you know the height at which the ladder, the upper end of the ladder touches the wall. Let us say that point is let us say this height is y. Okay. So, let us say you know this, okay, and you need to find what is this angle that the ladder forms with the wall. Okay. So, let us say that is the task. Now, to solve this problem, you need the concept of trigonometric functions, and let me illustrate why. So, let us change this problem slightly, that will help us. So, let us say the rectangular wall is here. Okay. Let us say this is the wall, and let us imagine that a ladder is hanging on this wall such that one end of the ladder is actually fixed, or you can say hinged. Okay. So, the ladder is hinged on the wall such that this end is fixed, this cannot move, the other end of the ladder is free. So, it can move in this direction or this direction. So, the ladder can move around this fixed end, okay, but this end cannot move anywhere, right. So, this end is fixed, but the ladder can move around. So, for example, if you give it a push, let us say in this direction, the ladder would make a circular movement, the other end of the ladder would make a circular movement like this and will come back here. That is the kind of movement we are allowing, right. So, let me redraw it clearly, and so that we can use it for our purpose. So, let us say this is the fixed end of the ladder and other end is free, and we are going to move this ladder such that it takes this circular motion. Okay. So, this is the ladder, the length of the ladder is r. Okay. So, it moves like this. So, let us say we are rotating it in anti-clockwise direction. So, we are going to give it a push in the anti-clockwise direction. Okay. You can start it anywhere. So, rather than starting it at the bottom position, let us say the initial position at t equals to 0, the position of the ladder is here. This is the other end. Okay. This end is fixed, this end is free, length of the ladder is r. Okay. Let us take this axis as the reference horizontal axis. Okay. This is our reference horizontal axis, so that we can do some computations. What kind of computations? We can compute because you are moving the ladder in anti-clockwise direction. At some point, let us say ladder reaches here. Okay. Now, you can compute how high is this other end of the ladder, let us call it P. How high is this end P from this reference horizontal axis? Okay, let us call that height y. Okay, and let us call this angle the ladder forms with the horizontal axis theta. Okay, and you already know the length of the ladder is r. Okay, so we can do these kind of computations. Okay, but before I go into that idea of finding height of the end ladders other end p from the horizontal reference ground, before going there, let me introduce you to concept of angle measured in terms of radians. Okay, so there is another measure in which we can measure angles, which is called radians, right. You already know how the angle is measured in terms of degrees. Okay, so if I ask you, let's say the ladder starts rotating from this point here, okay, and it keeps on rotating in anti-clockwise direction and reaches back here. So how much angle does it form from a starting point to the same to the point it reaches the same point again? So this angle, okay, how much is this angle from a starting point to the same point again? This angle is actually 360 degrees. Okay, and how much distance this point P has covered when it starts traveling from this point and travels all the way along this circle and reaches back here. How much distance this point P has covered? That's actually the circumference of the circle. And how much is the circumference of a circle? 2 pi r, where r is the length of the ladder or the radius of the circle. Okay. So now radian is actually an angle formed by an arc. You know an arc? What is an arc? So in a circle, you can take, let's say, a part of circumference, let's say this. This is called an arc. This arc would form an angle at the center. So if you just join center with these 2 points, it will be an angle like this. Let's say this angle is phi. So an arc forms an angle at the center. Okay. So radians is actually the length of this arc divided by radius of the circle. So for example, if the length of this arc is 2r and the radius of the circle is r, then the angle formed by this arc at the center is actually 2r by r equals to 2. Okay. So that's how we define angle in radians. More generally, it's basically circumference of the circle divided by radius, okay, or arc of the circle and divided by radius of the circle. That will give you the amount or basically how much angle that arc forms at that point, right. Okay. So now for example, for the entire circle, the circumference is 2 pi r, and how much angle the entire circumference makes at the center, that angle is 360 degree, right. So now this will give you an idea of how to convert degrees into radians, right. So this angle in degrees is 360 degree, but what is this angle in radians? In radians it is 2 pi r divided by r. Okay, so this is the length of the arc and this is the radius of the circle, which is basically then 2 pi. So what it means is that 360 degree is actually equal to 2 pi radians. Okay. So what would be 1 degree? 1 degree would be 2 pi by 360. Okay. That's the idea. So whenever you want to convert some degrees into radians, this is how you can do it. Okay. So for example, let's say you want to compute 60 degree. What would be 60 degree in radians? 2 pi by 360 into 60. So that would be 2 pi by 6 pi by 3. Okay. So this is the angle in radians. So when we are dealing with trigonometric functions, most of the times we would describe our angle in terms of radians, okay, because that's more easier to understand, and we will get all the angles in terms of pi. Okay. So for the entire circumference, the total angle is 2 pi if you reach back to the same point. So 360 degrees equivalent to 2 pi, 180 degree would be equivalent to pi, 90 degree would be equivalent to pi by 2, right. So this is 360, this is 180 degree, this is 90 degree, pi by 4, this is 45 degree, and so on. Okay. This is how these angles are. What if it is, let's say, 3 pi by 2? Now this is 270 degree. Okay. Pi by 2 is equivalent to 90 degree, 3 pi by 2, 270 degree. Okay. So we'll be dealing with angle in radians. That's why this concept was important here. Anyway, let us come back to our problem where a ladder is fixed. One end of the ladder is fixed, okay, and the other end is free. Okay. So, one end of the ladder is fixed on the wall, other end P is free, and we consider that this is a horizontal plane. Let us consider this the ground or whatever horizontal reference plane. Okay. So, let us say reference horizontal plane or ground. Okay. And we rotate this ladder in anti-clockwise direction. Okay. So, we rotate this ladder in this direction. So, let us say the ladder reaches here. Okay. So, this it would form a basically a circle. So, the point P would form a circle as we move this ladder because this end is fixed. So, let us say the ladder reaches here. Okay. So, we have moved the ladder upwards by an angle theta. Okay. So, the ladder the end P has reached here. We want to compute what is the height of this point P from the reference horizontal plane, okay, from this plane. So, let us say this height is y, we know the length of the ladder is r and this angle is theta. Okay. So, our task is to figure out what is the height of this point P from the ground, okay, y. Okay. So, we need to figure out what is y. What is given? R and theta. Length of the ladder is given and the angle the ladder forms with the horizontal plane, the theta is given. Okay, and we need to figure out y. Okay. Interestingly, let us say we move this ladder even more in the anti-clockwise direction. So, after some point the ladder reaches here, at this point basically vertical, okay, perpendicular to our horizontal reference plane. So, that means at that point this angle would be 90 degree or let us say pi by 2 in radians. Okay. And what is the height of this point from the ground? Height at this point becomes r, basically exactly same height as the ladder. Okay. So, we can actually write this at a particular angle pi by 2, okay, 90 degree. What is the height of this end P from the ground? It is r. Okay. And if you think about the starting point, we started here, okay, when the ladder was actually horizontal, it basically was lying on this reference horizontal plane. What was the height of this point P from the ground? 0, because the point P lies on this reference horizontal plane. So, when we just started, okay, and what was the angle? Angle was also 0, okay, it was not making any angle with respect to ground, and the height of point P was 0. So, when angle was 0, so let me write it like this: when angle was 0, then the height of point P was 0. When angle was pi by 2, okay, so angle was 90 degree, the height of that point P with respect to ground was r. Okay. Now, let us move it again in the anti-clockwise direction. Let us say the ladder reaches here, okay, at this point. So, when the ladder reaches here, what is the height from the ground? 0, because it lies in the horizontal plane. And what is the angle now at this point when the ladder reaches here? Okay. Now, the angle is not 0 degree, because you need to measure angle from this point, right. So, angle would be actually 180 degree. So, angle is pi here. So, when angle is pi, height of the point P is 0. Similarly, when the ladder reaches here in the downward direction, so the ladder is now hanging at this point, and the point P has reached here. Okay, this angle now becomes 270 degree, which is pi plus pi by 2, 3 pi by 2. So, at 3 pi by 2, height of the point P from the ground. Now, rather than writing r, you should write minus r, because the direction has changed. Okay, it is in the negative quadrant. Okay. So, the height is actually now minus r, so that we can include directionality. Okay. So, the height of the point P from the reference is minus r. And what if the ladder reaches back at the same point? Now, the angle becomes 360, 2 pi, and the height of point P with respect to ground is again 0. Okay. Now, even after reaching here, you can again move the ladder. Let us take the second rotation. Okay. This was just first, the ladder has completed one circle. Okay. What if we rotate it again? Okay, we are taking the second rotation. So, when we rotate it again, now let us say we rotate it by 90 degree again. So, total rotation has now become 2 pi plus pi by 2. Okay, so we can count it from when we started rotating it at time t equals to 0. Okay, so the ladder has been rotating since then. Okay, so the total angle of rotation has become 2 pi plus pi by 2. How much is that? 5 pi by 2. So, when angle is 5 pi by 2, the height is again r. Similarly, when angle becomes 2 pi plus pi, basically 3 pi, the height becomes 0, and so on. Okay. So, this is what we are getting actually. At when angle was 0, the height of the point P is 0. When angle is pi by 2, height of the point P is r. When angle is pi, height is 0. When angle is 3 by pi 2, it is minus r. When angle is 2 pi, the height is 0. When angle is 5 pi by 2, the height is r. 3 pi, the height is 0, like this. Okay. Now, this seems interesting, because it seems like that the function, if we think of height at point P, y, okay, if we think of y as a function of theta and r, okay, it seems like that y is a periodic function of theta. What does that mean? That as theta, value of theta changes, y has some value, but after a certain value of theta, and as theta is, you can it is visible in this graph as well, that for example, if theta is increasing from 0 to 90 degree, the height is also increasing from 0 to r. Okay. So, as you go from 0 to 90 degree, height is increasing from 0 to r, but as you go from 90 degree to 180 degree, now height starts decreasing. Okay, and then you again go from pi to 3 pi by 2, height decreases even further to minus r, and then again it starts increasing as you go from 3 pi by 2 to 2 pi. Okay. So, height starts increasing, then it decreases even further, then it again starts increasing. Not even that. So, this function is not monotonically increasing or decreasing, it is sometimes increasing then decreasing, and not only that, the function repeats its value. So, the function has same value at angle 0, at angle 180 degree, at angle 2 pi, at angle 360 degree. Okay. Similarly, the angle has same value at pi by 2, same value at 5 pi 2, 5 pi by 2. Okay. So, angle, so basically this function repeats its own value at a particular interval. Okay. This kind of function is called a periodic function. So, you can say that y is a periodic function of theta and r. Okay. Good. Can we think of, because in here basically what you are getting, at pi by 2 you get r, 3 pi by 2 get minus r, then you again get r. What if I rewrite this entire function as r into some function of theta. So, let us say there is some function of theta and you multiply r with that function of theta, okay, which is fine because we are seeing this r term multiple times in the value of the function. Okay. And what if we write y by r is a function of theta? So, what would be y by r? So, what were values of theta? So, let us say 0, pi by 2, pi, 3 pi by 2, 2 pi, what else? 5 pi by 2, 3 pi and so on. Okay. And what would be corresponding value of y by r? So, y by r will take a value 0 here, here because the value of y was r. So, this is r by r 1, this is 0, this would be minus r by r minus 1, this is 0, this is 1, this is 0. Okay. So, corresponding values are now between minus 1 and 1. Lowest value can go up to minus 1, highest value can go up to 1. Now, this is a much better function because now y is not a function of r. Okay. Rather, we have written it in form of y by r is a function of theta, such that this function can take values between minus 1 and plus 1. Okay. And theta can take any value basically in radians, right. So, theta is no constraint. Okay, good. So, we then basically can write y by r as a function of theta such that the codomain of the function is such that it can take any value between minus 1 and plus 1. Okay. This is how you can write this function. Okay. What is y here? Y is the height of rotating end P. Okay. This was the height of the rotating end P from the ground, from the reference plane. And what is r? R is the length of the ladder. Okay. So, what we are saying is that the height of the rotating end P, okay, let us say this is our ladder, this is the rotating end P, this is the fixed end, okay, and let us say this is the reference plane. We are saying that the height of the rotating end P, let us call this height y, and r is the length of the ladder. What we are saying that y by r is a function of theta. Y by r is a function of theta. So, height of the rotating end from the ground divided by length of the ladder is a function of theta. Okay. And we also know how this function behaves. This function starts its value at 0 because initially y by r is 0, then it reaches 1, then it basically it increases to 1, and then it starts decreasing, comes to 0, then decreases further to minus 1 and it starts increasing again. So, actually this function looks something like this. You can calculate this. Maybe you can take some rotating pen or something around one axis and see how it heights increases with respect to a reference ground. So, when the angle was 0, the height was 0. When the angle became pi by 2, 90 degree, height starts increasing. And it increases in such a way that increases rapidly in the beginning and then its rate of increase slows down, because remember it is going to also decrease now from this point. So, it becomes maximum at pi by 2 and then it starts decreasing such that it starts decreasing rapidly near pi. Okay. And so, at pi it becomes 0 and after pi it decreases even further and the rate of decrease becomes almost constant at 3 pi by 2. Okay. And after 3 pi by 2 it starts slowly increasing and increases very rapidly near 2 pi. So, at 2 pi it again becomes 0 and then it starts increasing again. So, at 5 pi by 2 it reaches maximum and at 3 pi it becomes 0 again. Similarly, even if you rotate the radar in the opposite direction, let us say you rotate it clockwise, The same thing would happen in this direction. At, let us say, minus pi by 2, the height would become minus 1, the height divided by length would become minus 1. So, basically this function on y axis I am representing this function y by r equals to f of theta. This is a function of theta. So, I am representing y by r on y axis, on an x axis I am representing theta. Okay. So, at pi by 2 it becomes minus 1, and at minus pi it becomes 0 again. Okay. So, similar thing happens on this direction. So, this is the behavior of the function y f of theta. Okay. So, this is a function for y by r f of theta. This function is called the sine function. Okay. So, you can call this f, this function f, a sine function. So, f is a sine function. Okay. So, in another way you can write y by r equals to sine theta. Okay. So, I replaced f by sine, that is the name of this function, the function that behaves in this way. Okay. It is a periodic function, it goes from minus 1 to 1, at 0 the value of the function is 0, at pi by 2 the function becomes maximum, and then it decreases and becomes minimum at 3 pi by 2. Okay. Such a function, such a periodic function is called a sine function, and what this function gives you is gives you height, the ratio of height of the rotating end divided by the length of the ladder. In a way, what you are saying that if you have any right angle triangle, see in this ladder problem we are trying to measure this angle, but this angle is already 90 degree. When we are measuring the height of this point P from the ground, if we think of this thing as a triangle, then this is already right angle triangle, this is the 90 degree. We call this length of the ladder is actually the hypotenuse of a right angle triangle, and this height of point P from the ground is called the perpendicular, and this is called the base, the height of this origin with respect to this point, right. This is called the base. So, this is a right angle triangle. So, we are trying to solve the right angle problem where this is the angle theta, this is hypotenuse r, this is perpendicular y, this is base x, and what sine theta is giving you is basically y by r, perpendicular by hypotenuse. Okay. So, perpendicular by hypotenuse is actually equal to sine theta, and you know what is this function exactly. This function behaves in this way. Okay. In your calculators you will always find this function. So, you can calculate the value of the sine function corresponding to any angle. So, in your calculator if you give, let us say, something like sine pi by 6, which is actually 30 degree. So, the calculator will give you an answer 1 by 2, like this. Okay. So, using sine function you can always figure out the height of the rotating end P from the ground. Now, let us go back to before let us go back to that problem. So, let us say you are given the height of the ladder is the length of the ladder is, let us say, 10 meters, and you are also given that the angle it makes with the ground is, let us say, 30 degrees, okay, which is basically pi by 6. Okay. Then what is the height? So, let us say theta is 30 degree, length of the ladder is 10 meters. So, what is the height of this point P from the ground? Basically, what is y? Now, you know y by r equals to sine theta, y would be equal to r sine theta. That means y would be, what is r? 10 sine pi by 6, and if you calculate this in calculator, sine pi by 6 would be actually 1 by 2, this is 10. So, the height of the point P would be 5 meters from the ground. Okay. Now, let us go back to our original problem. We had a wall and this is the wall, this is the ground, and there was a ladder standing against the wall. Okay. You are given length of the ladder, and let's say you also know this point, height of this point from the ground. Let's say that height is y. Our task was to find what is the angle that the ladder forms with the ground. We need to find this angle theta. Now you know from what we have deriven is that y by r is a function of theta, and what function? Sine theta. So y by r is a function of, is a sine function of theta. Okay. So we know y and r. Our task is to find theta. So theta would be actually an inverse function of sine. So you can write theta as sine inverse y by r. Okay. That's your angle theta. So theta is sine inverse y by r. Of course, similar to sine, in your calculator you would also find inverse sine function. If you don't find it, you can find it in some R or Python, some programming, right? So it would be sine inverse of y by r. So that's how you can solve that problem. All right, so that is the introduction to trigonometric functions. In the next lecture, we will talk more about the sine function, and we will introduce the cosine function as well. Okay. All right, thank you very much.